It is now well over 2 hours since I set up this experimental demonstration. I've connected the voltmeter to the pipeline, or the nail on the right, which is connected to the negative terminal of the dry cell battery. I have connected the other side of the voltmeter directly to the electrolyte, which is dissolved in the superabsorbent cloth. The milliamp meter is connected between the positive pole of the battery and the left-hand nail. There are 4.09 milliamps running from the battery into the electrolyte through this left-hand nail. These charges are travelling through the electrolyte onto this central nail at this end, which will not be corroded, and from this central nail into the electrolyte and onto this right-hand nail that will not be corroded. As you can see, there are 3.8 volts difference between the electrolyte at this point and the nail. If you look at the ammeter, you will see when I lift the absorbent cloth from the left-hand nail, you will see that the reading on the ammeter will lower. You will also see that there are stains from the corrosion product on the cloth where it has been in contact with the left-hand nail. When I lift the cloth from the right-hand nail, there will be no stains, but the amount of current shown on the ammeter will reduce. There are no stains on the cloth. The current has reduced and the voltage has more or less stayed the same. Now, on the centre nail, you remember that the charges are entering the centre nail at this point and leaving the centre nail where it is in contact with the cloth at this point. You will therefore see that the centre nail is not corroded at this point, but it is corroded at that point. Now, you can see that the charges are still passing from here into the cloth where they have caused the metal to go into solution, and the product is left there. The product is left here, and there is no product on this surface here. So this demonstration proves that obviously Faraday is correct, that charges leaving the metal dissolve the metal. So you can see that we have counted the charges here, and we can see on this meter that when I touch the nails respectively, this is the total voltage, this is the voltage of the whole of this nail, 3.69, 3.69, okay? So there is very little volts drop along this nail because it is one single metallic element, but there is a voltage between the cloth here and the cloth there. So this cloth is at 3.37 and this cloth is at 4.79. Charges will therefore come from this cloth onto this conductor and from this conductor onto this cloth. You can see the charge is clearer. I'm looking at this and there are corrosion products here and no corrosion products there. That concludes the visual observations, and now we come to the part where we can study the effect of switching the current off, and we can see on the oscilloscope the effect of switching the current off on the whole of the system.